Hello and welcome to Snappy Code Insights. Are you finding it tough to give a clear answer in technical interviews? You might understand the concept, but explaining it for things like how you built it versus how would you fix it can be tricky, right? Best way to tackle this to prepare yourself for different scenarios. Think about how you implement the concept, troubleshoot issues, optimize performance, or ensure security. These angles can make all the difference. I have put together a guide with 10 situation based questions which are frequently asked in Java, Spring Boot, Microservices interviews that cover key concept in various contexts. So if you are ready to boost your confidence and nail those interviews, subscribe my channel and join our WhatsApp group to grab this free guide. Let's start. How do you troubleshoot issues with Spring Boot's auto configuration not picking up custom bean in large microservice architect? Thank you for question. I would start to review the logs. Spring provide detailed warnings of errors that often point directly to root cause. Next, I would check configuration files to ensure that custom beans are correctly defined in configuration class. Next, I will enable debug mode by adding debug is equal to true in application.properties file. This will produce a detailed auto configuration report that shows which beans were created and highlights any condition that failed. Next, if Spring Boot has already defined bean of same type, custom bean could be ignored. In such cases, I would use @primary annotation on the custom bean to ensure it takes precedence over the default one. I would also examine if any conditional annotations that might be affecting the bean. Annotations like conditional on missing bean, @conditional on property, @conditional on class are commonly used to control bean creation. I would verify that conditions for my bean are correctly met. For instance, if beans are conditional on a property, I would check that property is correctly set in configuration file. Another area I would investigate is component scanning. If package containing my custom bean isn't part of component scan, the bean won't be registered. In such cases, I would use @components scan to specify package explicitly. I would also ensure that correct Spring profile is active. Sometimes bean can be loaded conditionally based on profiles using @profile annotations. I would check appropriate profile such as div or prod is active and matches the environment I am working in. Question number 2. How to disable specific auto configuration for one microservice while keeping it enabled for others. To disable specific auto configuration in Spring Boot, you can add exclude attribute to Spring Boot application annotation. Alternatively, you can control auto configuration via application.properties or application.yml by adding excluded class to spring.autoconfigure.exclude property. Create a custom configuration and use @conditional on property to conditionally enable or disable it based on a property. This allows more flexible and property-based configuration. In technical interviews, when we are faced with situation-based questions, it is crucial to listen carefully and understand the context behind the question. Sometimes questions may involve similar concepts, but they are framed differently. For instance, question 1 is asked in the context of troubleshooting, and question 3 is about implementation. Both are on bean management, but their contexts differ. Being aware of whether the question is about troubleshooting or implementation will help you tailor the right response. This demonstrates your ability to listen well and deliver focused and thoughtful response. Okay, let's answer question number 3. When dealing with multiple beans of same type, apply @primary to one bean. Make that bean default if no specific bean is requested. For more control, use @qualifier to explicitly select the required bean during injection, ensuring correct one is used. To prevent auto-configuration from overriding your custom bean, leverage @conditional on missing bean, which only allows auto-configuration if custom bean isn't already defined. Use @conditional on property to enable or disable configuration based on specific properties, giving you more control which configuration is active. If order of bean initialization is important, use @depends on to ensure that dependent beans are initialized in correct sequence. I find that many questions about optimizing performance and scalability under heavy load are framed differently, often lead to same fundamental concept. It's fascinating how same answer can be given to different questions, all leading to same key strategies for effective API performance. Those are load balancing for distributing traffic, caching to reduce data load, horizontal scaling and auto scaling for handling increasing traffic, asynchronous processing for non-blocking tasks, circuit breaker to prevent cascading failure, monitoring and tracing for identifying bottlenecks, compression and minimizing payload to reduce network overload. These are easy to remember, but there are still few more strategies. Please ask for PDF in comment section and follow the instruction provided in description. Let's answer this question. Start implementing load balancing to distribute traffic across multiple instances using tools like Spring Cloud Load Balancer or Netflix Ribbon. Caching frequently accessed data with Redis or eCache can drastically reduce database load and improve response time. We can implement horizontal scaling using Kubernetes or Docker Swarm to ensure your services can scale dynamically based on traffic. We can enable auto scaling to handle sudden traffic spikes. For long running tasks, use asynchronous processing with message brokers like RabbitMQ or Kafka to avoid blocking the main application flow. Utilize circuit breakers like Resilience 4Z to prevent failures from cascading across services. Monitoring tools like Prometheus coupled with Spring Cloud Sleuth for tracing and help identify performance bottlenecks. Finally, ensure your API is optimized by enabling ZZip compression and minimizing payload sizes to reduce network overload. Next question, how would you handle versioning of REST APIs when multiple microservices are consuming them and client still use old version? To handle versioning of REST APIs in microservice environment, you can start using URI versioning to clearly define which version of API the client is using. This ensures that client can continue using old versions without any interference. Another option is to use the accept header. It allows client to specify the version they need. Finally, you can include version in response header to let clients know which version they are interacting with. Make sure to maintain backward compatibility with older version as much as possible so existing client don't break. Implement a deprecation strategy to inform clients when older versions will be phased out, giving them time to update. Question number 6. Here is one scenario. You are building a REST API that serves product listing from a database with millions of records. Users can filter products by category, price, and rating. They can also sort product name or price. As traffic grows, clients are facing slow response times when retrieving large set of data, especially when using multiple filters and sorting options. Here is question: what strategies would you use to manage REST API pagination and filtering when dealing with millions of records from a database? Here is the answer. To handle pagination and filtering in REST APIs with millions of records, use either offset-based pagination or cursor-based pagination. Cursor-based pagination is more efficient for handling growing data, avoiding performance issues with offset. Apply filters on indexed field to improve performance, and use compound filters or range queries for more complex scenarios. Enable sorting on indexed field to prevent slow queries. Limit the number of records per request to control data load and avoid server or client overload. Next question: what is Spring Boot Actuator and how does it help in monitoring applications? Spring Boot Actuator is a tool that helps monitor, manage Spring Boot application by providing useful endpoints like health checks, metrics, and environment details. To implement it, you need to add Spring Boot Starter Actuator dependency to your project. By default, it exposes endpoints like /actuator/health, but you can customize which endpoints are available by configuring application.properties file. Actuator also supports metrics tracking and system information. In production, it is very important to secure this endpoint by using Spring Security. This enables easy monitoring and troubleshooting microservices. Next question: how to secure sensitive actuator endpoints in a production microservices environment? To secure sensitive actuator endpoints in production environment, you can start by integrating Spring Security and applying authentication for these endpoints. Enable basic authentication by configuring a username and password in application.properties file. You can also implement role-based access control, restricting access to certain endpoints based on user rules. Additionally, limit access by defining trusted IP addresses that can access the endpoints. It is also a good practice to disable sensitive actuator endpoints such as actuator/env or actuator/hit dump in production to reduce exposure of critical information. Finally, consider using HTTPS to encrypt all traffic, ensuring data confidentiality. Next question: how do you design a microservice with Spring Data JPA to handle dynamic queries on large dataset efficiently? To handle dynamic queries efficiently in Spring Data JPA, you can use pagination with Pageable to retrieve a limited set of results per request, which reduce memory consumption. Additionally, for dynamic query building, you can use specification which allow you to construct queries based on user input, ensuring flexibility and optimization. Lastly, ensure indexing of frequently queried field in your database to enhance the query performance and speed up searches on large dataset. Next question: if you have microservices handling different databases, SQL, NoSQL, how would you manage transaction and data consistency using Spring Data? Here is the answer for this. For managing transaction and data consistency in a microservice environment with different databases, SQL and NoSQL, you can use @transactional for SQL databases to ensure ACID properties. For NoSQL databases like MongoDB, you can utilize multi-document transactions, which are introduced in Spring Data MongoDB. Transactions are managed based on which NoSQL database is used. In the cases of distributed system, Saga pattern is used, where transactions are broken into smaller compensating transactions to maintain eventual consistency across services. Thank you for watching. I hope you found this video helpful for your technical interviews preparation. If you are looking for more tips and tricks and more questions, there are a lot of great stuff coming your way, so be sure to subscribe my channel. Also, don't forget to join our WhatsApp group. It is a great place to connect with others and share experiences and get extra resources. Just click the link below to join. Let's boost your confidence and nail those interviews together. Thank you.